And 850 sea miles from New York City. The green shaded sections of this map of Newfoundland show the more than 11,000 square miles of territory which the company controls and from which it draws the pulpwood required for the operation of its mill at Brook on the island's west coast. This is the Newfoundland forest, a vast green thicket composed chiefly of spruce and balsam fir, the softwoods used in the manufacture of pulp and paper. This forest area is comparatively free from damage caused by insects or disease. Fire hazard, another factor of prime importance in pulp and paper operation, is also very low. In order to utilize timberlands to the best advantage, it's necessary to have detailed maps showing the location of the timber and all the topographical features that affect logging operations. Aerial photography, the most efficient means of forest mapping, is used to secure this information. Roads, railroads, and the transportation facilities of lakes and rivers must all be considered, and the camp locations and cutting areas selected with the greatest care before a single tree is felled. Studied under a stereoscope, these photographs become relief maps that show clearly all the contours of the land. The best locations for logging camps, roads, telephone lines, and similar facilities can thus be planned with maximum accuracy in a minimum of time. More than half the company's holdings have been covered by these 7 by 9-inch photographs, taken from an altitude of 10,000 feet and having a scale of approximately 1,000 feet to the inch. Although aerial photographs are used for the location of timber stands and general mapping, timber cruisers like these travel the forests and, by recording measurements of trees on selected sections, determine the size and quality of timber and density of stands. Ownership of timberland, of establishment and upkeep of property boundaries. This transit party is renewing a line run 40 years previously. A considerable amount of surveying is also required for the company's engineering projects. Once the planning and location work is finished, the actual operations are begun. The first step consists of establishing roads and means of communication. These wilderness roads are constructed by using modern machinery and methods. Roads suitable for use by motor trucks are constructed quickly and at low cost. Many miles of truck roads have been built by the company. These roads are company-owned. The traffic on them is controlled, and they are built to standard designs to suit the requirements of logging transportation. The bulldozer or tractor with trail building attachment has revolutionized the building of wilderness roads. These machines, in the hands of skillful operators, speedily cut a rough road through the woods, carrying before them easily the trees and heavy obstructions that formerly were moved only by the labor of many men and horses. They push down trees and then push them clear of the proposed roadbed. They move dirt, gravel, and rock from high sections to nearby low sections of the road. When the bulldozers have finished, the road is well underway. Once the roadway has been cleared, the work of building up a suitable roadbed foundation over many sections of the ground begins. Portable power shovels dig into the deposits of good road ballasting materials that were left there many centuries ago by the receding ice cap that once covered Newfoundland as completely as Greenland is covered today. This sand and gravel is carried to all parts of the road where surface improvement must be made. The traffic on the road soon packs this material down to a smooth, long-lasting surface. In most cases, roads must be built before the camps can be established and supplied for the work of cutting the pulpwood. When the necessary roads are finished, the real work of cutting begins. Truckloads of gravel are shown being dumped on a large fill. Fills of this size are required only in the most difficult locations, and a thin layer of ballast is usually sufficient for good road surface. This is the completed road, a travel artery pushed through virgin forest at a rate of about a mile a week, a road over which supplies and men will travel winter and summer to reach the logging camps. Cars can travel over these roads at a speed of about 30 miles an hour, and they stand up well under the travel of heavy truckloads of supplies. At 1 mile intervals along the road, mile posts are set up showing the distance from the supply depot at Brook, the center of this network of communication and transportation facilities, where the mill is located. Brook, the leading city of western Newfoundland, is situated on the Bay of Islands, one of the world's most beautiful bays, lying near the center of Newfoundland's 300-mile-long western coastline. This paper mill, one of the most modern in the world, is capable of producing 780 tons of newsprint, sulfite, and other paper products daily. The large-scale logging operation required to provide the necessary pulpwood entails the consumption of great quantities of supplies, and practically all these supplies, food, clothing, and equipment, are shipped in from other countries. The company operates a cookhouse at each logging camp, and in normal years provides food and housing for about 3,000 men at certain periods of the logging season. Over 700 horses are used in the hauling of pulpwood, and thousands of tons of hay and other feeds are imported through the central supply store located at Brook. Supplies come to the central depot by rail and ship, and from there are distributed to the logging camps by rail, truck, sled, small boats, or a combination of one or more of these facilities. Hay that reaches Brook by rail is unloaded there and either placed in the supply store or loaded onto trucks and hauled directly to the logging operations. The amount of food necessary for the horses is equivalent or greater than that amount required for the men. Upwards of 1,300 tons of hay and 1,000 tons of other horse feeds must be distributed to the various camps in a normal season. The company owns and operates a fleet of trucks such as this one, hauling hay from the central supply store to one of the logging camps. As much as possible of the non-perishable supplies is freighted into the logging camps during the summer months, when trucks and other wheeled vehicles can operate at their best. 90-ton steel tugs imported from England and assembled on some of the larger lakes are used for the towing of pulpwood booms and supply scows. Even horses, trucks, and other units of heavy equipment are transported in this manner to the isolated sections where the logging is carried on. This scow is being loaded with supplies for one of the camps located on Grand Lake, which is the major body of water in a long inland waterway that stretches for a total distance of more than 80 miles and provides water transportation to a large logging area. The company built and operates a 15-mile tramway that's used to carry men and supplies from one of the main highways to the headwaters of the Humber watershed, providing fast and efficient travel by means of gasoline-operated rail cars and the cars they tow. Many logging camps are operated by the company each season. A camp consists of a cookhouse and mess room, 2 or more bunkhouses, a workshop, a storage shed, and a barn. The average camp accommodates 60 men, and its operating life is about 5 years. The primary cutting instrument is the saw, and to cut wood, saws must be kept sharp. Although filed and put into condition at the camps after each working day, frequent attention during the cutting hours keeps these instruments at maximum efficiency. The quantity of pulpwood cut at each camp varies from 3,000 to 7,000 cords per season. Axes are used to notch the trees. This notching controls the direction of the tree's fall and ensures a clean breakaway from the stump. With skill and good judgment, the loggers consistently fell their trees as near as possible to the swamping roads along which the pulp sticks must be piled. Felling trees with a buck saw is much less wasteful than cutting them down with an axe. The loss through chips, if cutting were done with axes, would amount to a section about a foot long at the largest part of the tree, and the saw is a faster cutting instrument for softwood than the axe. After the tree has been felled, it's branched by clean, accurate axe cuts so that the wood will stack neatly and occupy a minimum space when hauled or shipped. Using his saw as a measuring rod, the logger cuts his tree into 4-foot lengths. This operation is called bucking. During this process, the worker discards all unsound wood. Further culling and inspection is given the wood when it's scaled or measured after the 4-foot lengths have been piled by the side of the roadway. The piling is usually done at the end of the working day, and each pile of wood represents approximately 1 day's work for one man, or about 1 1/4 to 2 cords, with about 130 pieces of pulpwood to each cord. Payment for cutting is made on a piecework basis, with the cord, or 128 cubic feet, as a unit of measure. The cutting of pulpwood is the most important single phase of logging operations, since it requires the greatest number of men. All other phases of logging are dependent upon and build up around this basic operation. Cutting starts in the early spring and continues during the summer and early fall, but is usually completed before the snow is more than a foot deep. Cutting in snow of any greater depth is inefficient because of the increased wastage in the longer stumps left in the ground. The trees most commonly used in the manufacture of pulp are spruce and balsam fir. Spruce is preferred to the faster-growing fir trees because it yields a higher percentage of wood fiber, the material from which paper pulp is made, and a smaller percentage of lignin, a waste product at the mills. The trees average less than 1 foot thick at the base, with an occasional tree having a diameter of nearly 3 feet and a height of more than 90 feet. The pulp sticks are cut to a minimum diameter of 3 inches at the small end. The Corner Brook mills require about 360,000 cords of wood for an annual production of 200,000 tons of newsprint and 40,000 tons of export sulfite. 2,500 men are employed during the summer months to cut this amount of wood. Enough pulp sticks to make a pile 4 feet wide and 4 feet high and 547 miles long, a distance equal to the entire length of the Newfoundland Railway from St. John's to Port aux Basques. After the wood has been cut and piled along, where it remains until the spring floods come, and it can be floated or driven to the holding booms at the outlets of the rivers. Most of the wood is hauled by horses, with a lesser amount being moved by tractors. The majority of the horses used in this hauling are owned by the company. When the hauling season of approximately 100 days begins, the horses are taken into the woods to the logging camps. During the winter months, the necessary camp supplies and mail must be carried into the more remote camps by horses and sled, to others by truck or tractors equipped with snowplows. A great deal of preliminary work is required for driving. The camps are made comfortable for winter living. All camps are built to conform with government regulations, and in most cases are far superior to the required standards. Considerable attention is given to the welfare of the workers, with particular emphasis on the health and educational facilities. The main roads over which supplies must go to the logging operations are kept open by means of tractor-driven snowplows. Although as much as possible of the necessary supplies is taken into the camps by trucks and wagons during the summer months, the roads must be kept open all winter long for the hauling of emergency supplies, to ensure fast and adequate medical attention in case of accident or illness, for the delivery of mail, and the proper inspection of the camps and the operations. Snowplows of this type with supplies in tow make trips over the roads at frequent intervals to maintain them in good shape for travel. The average temperature in the Corner Brook area during the winter hauling period is about 20 degrees above 0 Fahrenheit, and the lowest temperature for the winter is about 10 degrees below 0. The annual snowfall is normally in the neighborhood of 42 inches. Because of its insular position, the average winter is decidedly milder than that experienced on the mainland of the continent at the same latitude. Snow clearance on the main roads of Newfoundland is carried out by skilled operators using mechanical equipment. The snow condition shown here occurred after a very severe storm, the worst for the winter. Tractors with slanting blades are used for these larger drifts. This high road is used for motor traffic between Corner Brook and the settlement of Deer Lake, 30 miles away. This type of snow-clearing equipment is necessary for only the very severe storms of each winter, when the high winds pack the loose snow in deep, heavy drifts. For the lighter snow-clearing work, fast-moving snowplows such as this converted truck are used to keep the roads in good condition for automobile and truck travel. 2 woods truck roads lead from this highway to the company's operations on Steady Brook and Upper Glide Brook. The company has several tractors operating on the long hauls of pulpwood from the point where it has been cut and piled to the landing from which it will be put out on the spring floods. At this stage of early winter, the loads are relatively light. Later on, when these lighter loads have packed the snow down to a hard hauling surface, 10 or more sleds carrying a total of more than 40 cords of wood will be pulled by a single tractor. 3 sets of sleds are used, one set being loaded and a second being unloaded while the tractor is engaged in the hauling of the 3rd set. To be most effective, tractors should be used on the longer hauls, and since most distances are less than 3/4 of a mile, horses are used for over 80% of this work. These sequences are filmed during a blizzard and show the most difficult working and hauling conditions likely to be experienced. The hardy and resourceful Newfoundland loggers are able to operate efficiently and cheerfully under these conditions. Frostbite and similar injury from cold is extremely rare among these woodsmen who know how to dress and how to care for themselves, whatever the weather. Due to the short length of the pulpwood sticks, the sleds for hauling them are built with a narrow rack or framework, studded with spikes to keep the 4-foot lengths in place. 10 or more sleds may be operated from a single camp. Over the average hauling distance of 3/4 of a mile, 70 cords of pulpwood can be loaded, carried to the landing, and unloaded there in a single working day. Often, as much as 2 cords of wood or a weight of over 4 tons in a single load. The roads are laid out in such a way that the hauling is downhill, and the general principle of hauling wood is to start at the farthest end of the road with the longest haul. While the roads are being packed down in the beginning with light loads, the driver may add to his load from time to time on his way down to the landing, improving the hauling qualities of the road gradually, until maximum loads can be taken directly from the snow-covered piles to the spot from which they'll be driven in the spring. While it may require considerable effort for the horse to start off with a loaded sled, once it's moving, it requires little effort to keep it in motion. Then the great demand on the horse is to control the load and keep it from going too fast. The handling of horses and sleds on the rough hauling roads, which are simply cleared trails through the woods, demands a good knowledge of horses and driving. The character of the road determines the amount of wood that can be taken in a given load and the speed at which the horses can travel. On the steep hills, chains are fastened around the runners of the sleds to act as brakes, and where necessary, as shown in this scene, a quantity of wood is secured in chains and towed behind the sled to act as a further brake. The wood towed in this way is piled on top of the load as soon as the steep section of the road has been passed. The arrival of the load of wood at the landing and its unloading at that point concludes the hauling operation. The pulpwood is dumped on the lake shores or into the stream beds, and there it remains until late April or early May, when the combination of heavy rains and melting snows provides the floodwater to carry it down the streams on its way to the mill. The water that flows through the ravines and valleys of the forest is the most important means of transporting wood from the place in which it grows to the mill in which it is processed to make pulp and paper. The early runoff that comes with a combination of spring rains and melting snows is used to carry off the major share of the season's cutting. But by means of dams in suitable locations, this power for transportation may be harnessed for use all through the summer season. Driving begins as soon as the ice goes out in the spring. The normal method of driving wood is to throw all the wood into the stream and permit the wood that is held up along the shores to remain there during the drive, since it creates a narrow channel through which the bulk of the wood will flow down unobstructed. After this first free flow of wood has been landed at the seashore or large lakes into which streams flow, this remaining wood or rear is also driven down. In driving the rear, the crew starts at the upper section of the stream and works down with the flow, clearing off all the wood as they go and using this excellent channel formed during the early part of the drive for this later operation. These sequences show the driving of the rear wood after the spring drives have been completed. The men who watch the shores to guard against jams or plugs are called channel tenders, and it's their job to keep the wood moving steadily without a holdup. Pulpwood can be driven through steep and rocky streams. The short lengths into which pulpwood is cut permit its being driven with a minimum of plugs or jams, and enables the driving to be carried out on small streams that could not carry timber of greater length. In this manner, the more expensive winter hauls are kept at the lowest figure. The value of this factor can be more readily understood when the cost of wood and its cutting is compared with the cost of transporting it from the spot on which it grew to the mill. The transportation of wood is 3 times as expensive as the operation of cutting and piling. This is the Deer Lake boom in the Humber watershed. About 75,000 cords of pulpwood, or 1/5 of the annual consumption of the mills at Brook, can be held here. During the driving and towing operations in the larger lakes, a certain quantity of wood goes adrift and floats ashore with the high water. As the lake level falls at the end of the season, the wood left on the beaches is collected and refloated in an operation known as sacking. Where conditions for sacking by hand are difficult, winch boats are used to drag the wood off the beaches to booms in the deeper water. The wood now being loaded into the trucks was cut on the Bond Bay drainage, adjacent to the Humber River drainage on the north. In order to avoid the expense of its shipment by sea from Bond Bay to the mills at Brook, a towing distance of 60 miles, with the extra hazard of having a large part of that course lie through the open and frequently rough water of the Gulf of St. Lawrence, wood from this area is loaded onto trucks and transported over the highway for the short distance of 2 miles to an unloading point on Rocky Lake in the Humber River drainage. When it finally reaches the salt water through this drainage, it is only 2 miles from Brook. About 5,000 cords of wood were handled in this operation each season.